So in this video, I'm going to go over the last technique that you really need to have a mastery of in order to do limits analytically. And these specifically have to do with trig limits. So we're going to talk about some trig identities and helping you understand how to do them that way. So if you don't remember all of your trig identities, that's okay. Here's a great place for you to go. If you look at the very first page in your textbook, on the back side of it are all of the trig identities you're ever going to need to know anyways. So it's okay if you don't have them memorized yet, but it would be helpful if you did go back, refresh your memory, just look them over a couple of times to try to make sure you can retain them in your noodle. So here's what we're going to do. I'm going to look at these first two real quickly because these are ones you can verify easily using graphical or numerical methods. And in general, it's just helpful if you have those memorized as well. So for instance, the limit as x approaches 0 of sine x over x, that goes to 1. The other one is the limit as x goes to 0 of 1 minus cosine of x over x goes to 0. If you can memorize those two, you're going to be good. So here's what I'm going to do now. I'm going to go ahead and look at 3 examples using trig identities that are going to help me out and kind of manipulate them in a way so that we can understand how to do them. Again, memorize these. These are a process. So here's what we're going to do. If you look at this first one, the limit as x approaches 0 of sine of 5x divided by 3x. Now, it kind of looks like the problem I did over here where we said the limit as x goes to 0 is 1. But notice, my coefficients over here are the same. In this case, they're different. Now, if you notice that, you're great. This is going to be easy for you because here's what we're going to do. I'm going to just tweak it so that these do have the same coefficients. Now, it's going to be harder to change this 5x inside of sine than it is going to be to change 3x. So that's what I'm going to do. I'm going to change the 3x into a 5x. The way I'm going to do that is I'm going to multiply the top by 3 so that those two 3's will cancel out. And if I want to make this a 5x on the bottom, I'm going to have to multiply the bottom by 5. But here's the problem. I can't just do that and it work out nicely. It's not going to make sense because if you multiply by 3 over 5, you have no longer maintained equality. You have to multiply and divide the same thing on the top and on the bottom. So in order to make that happen, I'm just going to multiply by the 5 and by the 3. Okay, so that way I'm essentially multiplying top and bottom by 15, but I'm still going to work out the same numbers that I want to. So like I said, these 3's are going to cancel, and this 5 is going to move out front. So it's going to be sine of 5x over 5x, and then I've still got that 5 and that 3 to deal with later. But that's going to be easy to deal with once I figure out the rest of it. Now, I'm going to show you another thing that we like to do in calculus that makes our lives really simple. What I'm going to do is I'm going to switch this 5x out for something easier, something that looks prettier. In this case, I'm going to switch it out for a u. We use u a lot in calculus, so that's just why I'm going to use that letter for now. Now, here's the thing. U is equal to 5x. All I did was took that kind of uglier expression, 5x, and turned it into something prettier u. Now, here's the thing. As x goes to 0, u is going to go to 0 too. Just think about it. If you plug in 0 into 5x, you're still going to get 0. So, that's all I had to do. Now, we already said sine of x over x is 1. So sine of u over u, guess what? Same thing. It's just going to be 1. But then I'm going to multiply it by that 5/3 I had. So 1 times 5/3 is just 5 over 3. And that's going to be my final answer for this first one. Okay? Now I'm ready to look at the next one. On the next one, we've got the limit as x approaches 0 of 1 over x times cosecant of x. Now, in case you have forgotten, again, your trig identities, it'll be important to remember that cosecant is the reciprocal function of sine. So it's actually 1 over sine of x. So that's what I'm going to do. I'm going to use this identity here, this fact, and I'm going to try to rewrite this ever so slightly that it makes more sense to me. So here I go. I'm going to do limit as x approaches 0 of 1 over x times 1 over sine of x. Now, hopefully you guys know that when you divide by a fraction, you're essentially multiplying by the reciprocal. So here's what I'm going to do. I'm going to multiply by the reciprocal of this out front. So it's going to become the limit as x approaches 0 of 1 over x times sine of x over 1. All right, I'm going to go ahead and multiply. We're going to get sine x times 1 and x times 1, which is just x, okay? Now, I'm back here. The limit as x approaches 0 of sine of x over x. We said right off at the beginning, that was 1. So, makes my answer really easy, again, as long as I know this identity to start with, Okay. Now, I'm going to do one more example, and this one's going to be slightly different because, again, it's going to use another one of these identities. It's just in a different identity. Now, in this case, I'm going to do the limit as x approaches 0 of sine of 2x over sine x. Now, the identity I'm going to use in this case is a double angle identity. Now, I'm going to go ahead and turn the computer a little bit so you can see me a little bit better. So, in this case, I'm going to do the fact that sine of 2x is equal to 2 times sine of x cosine of x. Again, if you don't have that identity memorized, it's right in the front of your book. It's not something that you have to exactly know right this second. You can always just go in the front of the book and look it up right now. Now, on a quiz or something, I'm going to give you the identities to try to help you retain information, just so you're not having to go look for it. But so here's what I'm going to do. I'm just going to switch this red part out for what's on top. So I'm going to do the limit as x approaches 0 of 2 sine x cosine x over sine x. Now your big brains are probably thinking, hey, I can get rid of those signs. Absolutely, get rid of them. So we're left over with the limit as x approaches 0 of 2 times cosine of x. Look at that, so much easier. If I plug in 0 into cosine, that's going to turn into cosine of 0, which is just 1. So we're going to do 2 times 1, which is just 2. And that's my final answer. And I'll bet you right off the bat, you didn't think about that one because, again, sine of 0 is 0. That would have been an indeterminate form, but now we know the answer. It's 2. All right. Hopefully that helps you guys out, and make sure if you have any questions, please let me know.